Hey, I know this might sound like a really basic concept, but there's a lot of little subtlety that people can get lost in. So let me explain one of those pieces of information. Uh, we're taking a figure like this PQR figure right down here, this one that's in blue, and you notice they want us to do a scale factor of some amount, like 3. Like the K is 3. And all you have to do is multiply each one of the coordinates, whatever the coordinates are of Q, whatever the coordinates are of P, whatever they are at R. You multiply all those numbers by 3, and that gives you new coordinates for the image. Now listen, here's the part that I think sometimes people get lost in or forget or don't pay attention to. Do you see how there's like little tick marks on the image, right? So like it's kind of hard to see. Maybe my graph isn't big enough here, but there's little tick marks. That signifies that we have the image after it's been, the original figure's been manipulated. It's been enlarged. So if we came back to our notes, I think there's something that we want to add into our notes. Let's go back and look. The pre-image is going to have just basic letters for the points. It'll have like, A, B, C. The image is going to have like A with a little tick mark on it. I say A prime. That's usually the way mathematicians read it. And it'll have B prime and C prime. So let's go over and try one, and I'll maybe make it a little bit clearer what I'm talking about. If you're not paying attention, you can get lost at which one the image is, which one the pre-image is, all that kind of stuff. First of all, the thickness of the pen's driving me crazy. So because the scale factor is 1/2, they want us to do all these points. They want to graph them, and then they want us to do a scale factor of 1/2. They're telling us that it's going to be a reduction, okay? And you notice that they're saying the vertices of triangle T prime, R prime, and S prime are going to be half the value of the coordinates of TRS. So let's first graph TRS. So if I go -4, this is good practice for our just basic graphing skills. And then 0, 6, so that's up here, right? 0, I'm not going left or right at all, I'm going up 6. And then I go over 4, and I go up 3. Here's my last point right there, that's S. Okay, so we got S, we got R, and then we've got T right down here. So when I graph the new 3 points, all I need to do is take -4 and multiply it by 1/2, okay? And then I'm going to take the -5 and I'm going to multiply it by 1/2 and figure out those numbers, right? That's going to be my new ordered pair. My new ordered pair is going to be -2, -2.5. So let's graph that one. So I go -2, -2.5 right there. That's where my T prime is going to be. That's how you show that information. This was T, right? And now we have our T prime right here. All right, let's do another one real quick. I'm going to take 0, 6. So I'm going to take 0, and I'm going to multiply by 1/2. Well, that's obviously 0 there. And then I take 6, and I multiply it by 1/2. I guess I'll put parentheses around everything here. All right, and so that gives me 0, 3. So that's my new coordinate for R. That's going to be my R prime. So I go 0, 3. You might say, gosh, this doesn't seem very difficult, Nelson. I just don't want you to get lost with these little tick marks, the T prime, R prime, somebody saying, hey, what the heck is that? Or the word image and pre-image and all that kind of stuff. So let's do the last one. I go 4, 3, and I multiply those by 1/2. So 4 times 1/2. And I get, well, 2 obviously for that one. And 1/2 times the 3 there. So we got 3 times 1/2. Okay. And that gives us 1.5. So that's our S prime. Okay, so let's do that. So I go over 2 and I go up 1.5. That's my S prime right there. All right, now I'm afraid if I connect all these with lines, it's maybe going to go right through my letters, but whatever, I'll draw them in there. So there's our image, and this was our pre-image right here. Okay, so I hope I'm making this clear. It got reduced by a scale factor of 1/2. Okay. So what if we were trying to do the opposite thing? Like we were given a graph and we're trying to figure out what the scale factor is. Well, you can see here's our image out here. This is our image. And then this is our pre-image in here, right? Because it doesn't have the little tick marks on it. So we're going from a smaller figure to a larger figure. So this is definitely an enlargement. And if I get a scale factor that is smaller than 1, then I'll know that I have my comparison flipped upside down. I have the division going the wrong way. So I'll explain that here in just a second. First, we need to find the lengths of some corresponding sides. So when I look at this side, like let's say right here, it corresponds with this side right over here, and I can kind of confirm that because this is letters B and C, and this is B prime and C prime, right? Or this one right here corresponds with this one. So we want to find a pair of lengths that are corresponding. It doesn't matter which ones you find. Any pair will work. So if I look, let's say at this one right here, and let's zoom in. Now I want you to notice when I zoom on my program here, wherever I put my mouse, it zooms in on that. That's our center of dilation. If I put the mouse over here, it'll zoom out. It'll make it a reduction based on wherever my mouse is sitting. So if I put it right here, now watch, there's a number that shows up in the center of the screen. That's our scale factor right there. So we're getting it like 140 times bigger than, or not 140 times, 140% of what it was. So that's my center of dilation because that's what I kind of wanted to focus on. Well, what is going on here? We're going up 1. Oops, I want my pen on. We're going up 1 and we're going over 1. So the lengths of that right triangle are 1 and 1. So I could do the Pythagorean theorem here. 1 squared plus 1 squared equals c squared. I get 2 equals c squared. I get c equals the square root of 2. So CB is the square root of 2. Let's find out how big C prime, B prime, C prime is. So we go up 1, 2, 3. 1, 2, 3. Oh, well, wait a minute. We've just, made that 3 and 3. Our scale factor has to be 3, right? It has to be an enlargement of 3. But let's just check it out real quick. I think that's what's going to happen, but let's just check it out. So we go 3 squared plus 3 squared equals c squared, right? We get 9 plus 9 equals c squared. I get 18, right? So I get 18 equals c squared, and we take the square root of both sides. We get c equals the square root of 18. It's a little hard to tell. That doesn't look 3 times bigger, does it? So let's try to simplify this square root sign. So when you simplify a square root sign, you look for perfect squares like 4, 9, 16, 25, 36 that would divide into 18. Do one of these numbers here divide into 18? Of course it does. 9 does, right? So we're going to write 18, or the square root of 18, as square root of 9 times the square root of 2. And the square root of 9 is equal to 3. So I'm taking the square root of 9 right here, and I'm just going to write it as 3. And I'm leaving the square root of 2 alone. So I get 3 square root of 2. Hey, notice this. We had square root of 2 for C. Now we have 3 square root of 2 for C prime, B prime. So it's definitely a scale factor of 3. So my scale factor, we often use K for our scale factor, is 3. And I'm just showing that, finding the corresponding lengths sometimes, isn't necessary if you can see, what the enlargement is from the amount that we're counting up and the amount we're counting over, more or less kind of like the rise and the run, right? So this rise here was 3 and this run was 3. This was 1 and 1. So we're taking the the image divided by the pre-image, right? To find the scale factor. So it's always the image divided by the pre-image to find the scale factor, all right? And do you really need the side lengths of the triangle to do that? Not really. Sometimes it's easy to get the side lengths. If it's like a horizontal length, then you can just say, hey, the side length is 2. And you don't need Pythagorean theorem to do that. But I just wanted to show you that that's what the book is recommending. Find the lengths and compare the lengths that way. But like I said, the rise and run will tell you the same kind of information. Hey, I hope I'm making this clear. I know you can do the homework. We've just done 4 examples together. Call me over if you need some help on any of the homework. Thanks for watching.